Today's speaker is Oliver Rittman. So he is a PhD candidate in the Center for Doctoral Studies in the Social and Behavioral Science and a research associate at the University of Mannheim. He holds a master's degree in political science from the University of Mannheim and a bachelor's degree in social sciences from Heinrich Heine University of Dusseldorf. I'm sure I messed some of that up. In his research, he uses machine learning methods to analyze large corpora of audio-video recordings of parliamentary debates, predominantly in Europe. He uses these methods to shed light on discriminatory behavior in parlance and to better understand the relationship between verbal and nonverbal political communication. So with that said, I will turn it over to Oliver, and then Oliver has agreed to do Q&A while the talk is going on. If you have any clarifying questions, just raise your hands, the little hand emoji, and then I will unmute your microphone so you can ask your questions. Otherwise, we'll do more general questions at the end of the talk. Oliver, take it away.
All right, thanks a lot, Bryce. It's great to have the opportunity to present here, so thanks for the invitation. The work that's been done at C-SPAN and with C-SPAN data has been, important for us, especially Bryce's work has been a big inspiration, and I think our work wouldn't be where it is without that work that has been done at C-SPAN. So as Bryce said, I'm a PhD candidate. My name is Oliver at the University of Mannheim. My dissertation, I work with video data, video and audio recordings from different parliaments. Partly they also come from the US, so also come from C-SPAN, but what I'm talking about today comes from Germany, from a state parliament in Germany. You'll hear about this in a few minutes. I want to start with a couple of headlines that are in the spirit of headlines that I saw quite some years back now. And those headlines have in common that they all report on statements by women MPs who spoke with the media to share their experiences they had in their everyday work in Parliament. Here's an example from the Telegraph from the UK. The headline basically gives it away. It says male MPs were accused of not listening to women and telling them to shush. The ones that I originally saw mostly came from Germany, from MPs of the German Bundestag. Here's a German one from Zeit Online, large German newspaper. Quotas in German also comes from a German MP, a female MP, who reports that when women start talking in Parliament, other men start turning around, they mumble, they stop listening. And then there's another one from Spiegel, also German magazine, that reports the results of a survey among MPs who share similar experiences. So there are those experiences that were shared by women MPs, and as someone who works with video data, I was of course thinking that, well, this is something that we should see in video recordings in Parliament. Nowadays, most parliaments, most democratic parliaments have video cameras. However, mostly those cameras show the person who gives a speech rather than the audience. In order to observe that sort of behavior, you need video footage of the audience. Luckily, at that time, I was also starting to get involved in a research project where the people that I'm working with managed to start a collaboration with the state parliament here in Germany. And this collaboration allowed them to get raw video footage from cameras that show actually the audience of the parliament and not only the speaker. So this was a great opportunity for us to actually test whether we can observe this sort of behavior empirically. So we started this project that asks a rather straightforward question, which is it true what those female MPs were reporting? Do female legislators, when they speak in Parliament, indeed receive less attention than their male colleagues? And this is joint work with Tobias Ringwald, who is at the Karlsruhe Institute of Technology, and Dominic Nie, who is at Leibniz University of Hanover. And I want to emphasize that this is interdisciplinary work. Dominic and we are political scientists, and Tobias is a computer scientist who works in and is specialized in computer vision. So he's the guy behind the technical implementation behind the stuff that I'm going to present to you today. Okay, so we're interested in inequalities regarding the attention that female MPs receive in Parliament, but this, of course, builds up on quite a comprehensive research body on inequalities between men and women in legislative settings, also in political in general. I want to acknowledge that there's quite a lot that we already know. Most of this research that has been done helps us to understand how the organization of different parliaments, how the institutional design of those parliaments, how they create barriers that women have to overcome when they want to participate in politics, in like legislatures, that men don't have to overcome. Those may be rooted in the electoral system, those may be rooted in rules of the parliament, also structural socioeconomic inequalities, parties, electorate. So there's a lot of work. What has been recently more acknowledged is that inequalities, barriers don't always need to condense in institutions. Instead, they can be quite subtle. Now, subtle doesn't mean that they are less important. They can also pose significant barriers, but oftentimes this means that those inequalities are more difficult to observe systematically. If you, for example, think about whether MPs pay attention to a speech or not, this is something that's hard to observe systematically. We rely on reports from women who experience this, but it's hard to do research with this because, well, we need data for that. So maybe that's the reason why we have so far less research on such subtle inequalities. So in the project that I'm talking about today, we focus on one specific inequality, which is inequalities in attentiveness towards speeches by men and women. We think that this is something important to look at because if this is true, then it would marginalize women's voices in parliament, would pose a significant barrier to their participation in parliament, to their participation in the deliberative process of the parliament. It certainly would not be compatible with the normative standards of such a legislature, where each voice should be heard equally, or at least if there are inequalities, then this shouldn't be based on factors such as gender. Also, we think that if we find this pattern in a parliament, in a highly public setting that is subject to social norms, where legislators sit who know that they are recorded, then this finding is not unlikely to generalize to other forms of interaction. So if we observe this in parliament, we think that this is probably also true in everyday political talks, in closed meetings of a parliament, and so on. Okay, so the challenge, as I already said, is to kind of find data and find a way to measure whether legislators who sit in parliament are attentive or not. And as I already kind of told you, this won't come as a surprise now. We rely on camera recordings or video recordings of parliaments. In a German state parliament, it's the so-called Landtag Baden-Württemberg. I will give you some background information on that in a second. But to get started, it's important to kind of see where this footage comes from. So here on the left, you see a picture of the Landtag. They have 3 cameras. They also have a homepage where you can watch live debates. You can watch past debates. The footage here mostly comes from camera 3, which shows the speaker's desk and consequently the person who gives the speech. Here and there you see footage from camera 1 and 2 that shows the audience. However, we managed to start a collaboration with the Landtag, also with the local broadcasting company, which allowed us to get raw footage, raw and uncut footage of camera 1 and 2 here. You see 2 screenshots from those cameras, and you see, well, they capture the parliament and they allow us to observe whether MPs pay attention to what's going on in front of them or whether they don't. So you see this quite clearly here. I hope you see my mouse, but this guy is doing something on his phone. Those 2 women here, they seem to pay attention. So this can be used to now check whether MPs are attentive or not. Okay, so to give you some background information, we are in Germany. Germany is a federal state, has 16 states. They are called Länder, and each state has a parliament. We look at the state parliament of one of those states, Baden-Württemberg, which is in southwest of Germany, highlighted in purple here. We look at this in the years 2018 and 2019. On the right, you see the picture from before again, where you see the party composition of the Landtag at that time. The Landtag has 143 seats. And in 2018, there were 5 party groups. The biggest party group was the Green Party with around 30%, 47 seats. A little bit smaller, a Christian Democratic Party group, which you see in orange. So green, that's the Green Party group. Orange, that's the Christian Democrats. Then there's the AfD, Radical Populist Right Party, that you see in light blue on the right. 20 seats, 14%. The Social Democrats, red on the left, and then there's a small party group, the Liberals, which are in the middle here with 12 seats. During the time, there is a governing coalition between the Green Party and the Christian Democratic Party. Together, they have just above 60%, so they have a majority of the seats. In total, there were 25% women in this parliament in 2018-2019. However, those 25% were highly unequally distributed within parties, and that's going to be important later if we will analyze our data. So I want to stress this right now. The Green Party group has almost as many women as men, 46%, 22 out of 47 MPs are women in the Green Party group. There's the Christian Democratic Party group with 10 out of 43, so their descriptive representation is already substantially lower. But then there are 3 party groups with very, very low descriptive representation of women. In the AfD, there are only 2 out of 20 MPs female. Social Democratic Party group, 2 out of 19. And in the Liberal Party group, 1 out of 12. So we have 1 party group, the Green Party, where there are lots of women, Christian Democratic Party, also some women, but then 3 party groups with almost no representation of women. So that's something you should keep in mind for later. All right. So as I said, we have video footage from 2 cameras that show the parliament, that show the parliament's audience for 1 year of plenary sessions between July 2018 and July 2019. During that time, there were 30 session days. We will analyze video footage during 137 debates. And during those debates, we have a little bit under 1,000 speeches that we can draw on. It's also important to note that those 2 cameras usually do not capture the entire audience. Instead, they focus on specific party groups. So that's a downside of the footage that we are going to use. And the perspective, the focus of those cameras will change from speech to speech. Usually it will be the case that if, for example, an MP of the Green Party group gives a speech, then one of the 2 cameras will focus on the Green Party group in the audience. The other camera will focus on some other party group. You will probably also have some more MPs on the left and right, but you won't have the entire audience typically. Okay, so we have 1 year of video recordings. We could theoretically use them, watch them over and over again and code who's visible and whether they're attentive. However, that would take an incredible amount of time, and we don't think that would be feasible. Which is why we started this collaboration with computer scientists to automate this approach, to use computer vision techniques, automated computational techniques to do that job for us. And in general, in order to get a measure of attentiveness for MPs, we have 3 goals that we need to meet here. First, we want to detect faces. We want to detect all the faces that are visible in the picture. Second, we want to recognize those faces. So we want to know who those faces belong to. And third, we want to classify faces as being either attentive or not attentive. So this is an example here. Legislator A, B, C, and D. They do something on their phone. They're reading something, but they're not really paying attention to what's going on in front of them. Legislator E looks towards the front, so he's paying attention. And we want to build a pipeline that tells us this just from giving it the footage, right? Okay. So this is how we do it. We kind of translate those 3 steps. In the first step, we want to detect faces in the video footage, for which we can use something that is pre-built, ready to use. And we use a neural network architecture that's called Tiny Face. And as the name says, it's built to detect tiny faces in pictures. was introduced 2017 by Hu Ramanan. You see here an illustration they use in the original paper, and you clearly see what this is made for. It's made to detect faces within pictures, and it's also made to detect very tiny faces. We can very well use this to detect faces in our footage, not as many faces as on the left side, but it works quite well. We apply this and we now know, well, where are faces in our video footage? In the next step, we want to recognize faces. So we want to know who which face belongs to, which is why we need facial recognition models. Facial recognition in general, and that's great for us, is one of the most deeply studied areas in computer vision in at least the past 4 decades, which means that lots of resources went into this field, and now there's a pretty advanced technique on this, which we can build up on. The goal here is to identify persons based on photographs of the person. And there are, in general, different solutions to that problem. The solution that we are taking here builds on convolutional neural networks. And the task that those networks need to do for us is to assign the names of legislators to the faces that we have detected. I want to give you a very rough idea about how those convolutional neural networks work. If you're interested, around 2 years ago, I gave a talk at the International Methods Colloquium where I explained this in more detail. It's not about facial recognition, but about convolutional neural network, and the methodology behind this is rather similar. Convolutional neural networks today are the networks that are used mostly if we deal with visual data, and they typically consist of 2 stages. First stage is a convolutional base, and the second stage is a prediction network. Those are just fully connected layers, so a typical neural network. The convolutional base is what makes this network a convolutional neural network. And what this does is it extracts features from our input, and in the best case, it extracts features that will be useful for the task that we are dealing with here. In this case, the task is to recognize faces. So hopefully the convolutional base will take the input and it will extract features such as the eyes, the ear, hair, maybe the tie, that give us information about who's visible in that specific picture. And once the picture is passed through the convolutional base, it results in a feature vector. This is then passed into the neural network that does the prediction task. In our case, the prediction task is a multi-classification task, where we need to classify this guy here into one of the 150-something legislators that are in the parliament. Softmax activation will give us a probability that this belongs to any of those legislators. We're going to select the one with the highest probability, which is hopefully the name of the person who's visible here. In order to train such a network, we need training data, and we collected quite a rich set of training data. We have a finite set of legislators, in total 153 legislators, a little bit more than there are seats, but that's because there were some changes during that year. And we collect photos and video clips. So we have at least 5 minutes of video footage of each legislator. We have frames from them when they were sitting in parliament. We sometimes also have some photos from social media, which we use in order to train the network. And then we use a pre-trained architecture, and that's something that works very well with convolutional neural networks. This convolutional base here, because what you need in information to do one task often is also helpful to do other tasks, which is why for those networks, it's a typical thing that it's called transfer learning, that you use pre-trained networks that accomplish your task, and then you only train the second part, which is the part that does the task which you want the network to achieve. So we use a network, ResNet 18, pre-trained on the ImageNet. It's an architecture that we, in our work, use for many different things, and it usually works quite well. And we fine-tune it with our own legislator names, so the training data that we collected before. In order to test whether this works, we apply to a whole validation set. We find that it gives us the correct name in 99.7% of the cases. So it works almost perfectly. It may, like, you may think this almost works too well, but you can put this into context. It's good to remind ourselves that what typically makes facial recognition difficult is very little training data and lots of faces you have to choose from. In our case, we have a finite set, like 150 legislators to choose from, and rich training data, which is why this probably works very, very well. State-of-the-art problems in like facial recognition research deal with much more difficult problems. Okay, so we have detected faces, we have recognized faces. Now we want to know whether those MPs are attentive or not, which means we need another model, and we again train a neural network that now has the task to classify faces as being either attentive or not attentive. For that, we again have to collect training data. This time we have 46,000 images that were annotated by 4 coders. I was one of them. Those images look like this here. You have, this is a random sample, 5 images that were coded as attentive. On the left side here, we see those MPs, they look towards what's going on in front of them. On the right side, those are examples of faces that were coded as inattentive. This guy is doing something on his phone. This guy probably as well, reading something. They're not looking towards the speaker's desk. That's why we code them as inattentive. We use a very similar procedure as before. Again, a ResNet, a deeper ResNet, 34 layers, but again, pre-trained on the ImageNet dataset as our convolutional base and fine-tuned with our own labeled data. And the task is to classify each detected face as inattentive or attentive. Again, tested out of sample. Here we find that the network predicts attentiveness correctly in 86.6% of the cases. This is 13 out of 15 images. We found this to be very similar to intercoder agreement scores, and we wouldn't expect the network to outperform intercoder agreement scores. Intercoder agreement scores means that, like, if different coders code the same picture, they don't always agree on the label. And this is because sometimes it's just not perfectly clear whether someone's attentive or not attentive. And in that case, the network also couldn't give us the definite answer. So, and we are very happy with the performance of this network. And we think that it gives us reliable data that we can work with and that we can do research with. Okay, so we have those 3 steps we applied to our corpus of video recordings. Again, 1 year between 2018 and 2019, 988 speeches. Gives us a lot of data, for each frame, for each visible legislator, we know whether they're attentive or not. And we want to aggregate this in a way so that we can use it for our project. And we do this on a basis of individual speeches. So for each legislator who's visible in the speech, we calculate the share of frames that were classified as attentive relative to all frames, which gives us a measure that tells us like how long over the course of the speech a legislator was attentive. If this score is 1, this means the legislator was attentive during the entire speech. If it's 0.5, the person was attentive 50% of the speech, so half of the speech attentive, half of the speech inattentive. If it is 0, the MP didn't pay any attention throughout the entire speech. Okay, getting to the results, we start by comparing average levels of attention towards speeches by men versus speeches by women, with a simple mean comparison to see whether it is true that women receive less attention than men. So what you see here, the greenish dots represent one speech, and we average across the attention scores of all legislators in the audience. So this outlier here, it's at around 75%. So the average attention during that speech was 75% of the time people were attentive versus not attentive. This is a positive outlier. Usually the scores are much lower. Purple are the averages for men versus the averages for women. And we see that the average for men is indeed higher than the average for women. On the right side, you see the difference with standard errors. And this is actually a significant difference. Women seem to receive on average less attention than men do. In the next step, we distinguish the audience between men and women who are listening to those speeches to see whether this is true for both men and women, because it could be the case that men listen less to women, but women listen less to men, or any other pattern could create what we see here. If we only look at men and we see that the difference persists, it even gets higher. We have now a difference of 5 percentage points. To give you an idea about what this means substantively, this means that if a speech is 5 minutes long, then each legislator in the audience pays 15 seconds less attention on average. If we only look at women in the audience, we don't see this difference anymore. If anything, women pay more attention to women than to men, but we don't really know. 0 is included in the confidence interval, so it seems that nothing's going on there. Men listen less to women or pay less attention to women. Women don't. So that's our first result. On average, women in the Landtag Baden-Württemberg, they receive less attention than men on average. This difference is exclusively driven by men. Women seem to pay equal amounts of attention to their women colleagues as they do to their male colleagues. There are some concerns about the simple mean comparison. In my opinion, those mostly come from the fact that the cameras don't always capture the same corner of the parliament. And it could be the case, because this also correlates with who gives the speech, that cameras, when women deliver speeches, capture party groups that are generally more or less attentive than when men speak. And this may introduce some sort of confounding selection mechanism. To address this in the next step, instead of just comparing levels of attention towards of different speeches, what we're now doing is we are tracing listeners over time and only look whether specific MPs pay on average more attention than women. And this will also give us a better idea about how the data looks like here. So what you see in this graphic is a blue line that connects 2 dots, and it reflects the behavior of one specific MP. On the left side, we see the average attention of this MP when men speak. So this MP seems to pay little more than 60% of the time attention on average towards speeches of men. On the right side, we see the same, but for female speakers. So here the difference is quite clear. The same MP pays maybe 30% of the time attention when a woman delivers a speech. Negative slope means the person pays less attention on average to women than to men. Here's another line that is about another MP. This is yellow, and this is a positive slope, which suggests the other way, which is that this MP pays more attention to women than to men. The average score for women is higher than for men. And because the slope is positive, I gave it a different color. So this is yellow, meaning more attention to women than to men. Here the line is blue, meaning more attention to men than to women. And we now can look at the full picture to see like what's more common. Are there more people who listen more to men or more to women? And we see this is rather blue than it is yellow, suggesting what we saw before. Well, women receive less attention, even if we only trace listeners over time. If we implement this with a fixed effects regression that has listener fixed effects, we see the same thing and pretty much the same finding as before. Can now take those lines and filter out only men and only women. When we only look at men, it remains pretty blue. Maybe it becomes even more blue, suggesting, well, it's the men who listen less to women. If we only look at women, something very interesting happens. Picture suddenly is quite yellow. So there are women who pay more attention to women. The fixed effects estimate here even suggests, well, maybe women pay more attention to women than they pay to men. At the very beginning, I said that you should keep in mind that women are highly concentrated within party groups. And one thing that we find is that co-partisanship makes a huge difference for how much attention you pay to specific speeches, in a way that MPs pay more attention to speeches by their co-partisans. So if they share the same party, they will pay more attention. Now, those lines that reflect women here, most of them refer to the Green Party group. And here are like other women in parliament, and the chance that when women listen to women, so when, for example, women from the Green Party group listen to another woman who speaks, the chances are high that this woman is in the same party group as they are. So it's unclear whether like this positive, slightly positive effect here, whether this is driven by co-partisanship or not. In the same way, if a man listens to a man, there's a high chance that this person comes from another party group. It's higher than when you are a woman. Suggesting what we should control for here is co-partisanship. And indeed, as soon as we introduce a control variable that indicates whether the listener and the speaker share the same party, the positive effect that you saw here disappears. The negative effect for only man persists. It even gets stronger around the same magnitude as the one that we saw before. So second result is, even if we trace listeners over time and control for co-partisanship, the results from before hold. Women on average receive less attention than men, and this comes from men in the audience, not from women in the audience. There are some interesting remaining questions. We would like to understand how this difference comes about. One possibility is that this is just like discriminatory behavior, and we just listen less to women, but it also could be that other structural inequalities drive this result. Could, for example, be that women, due to structural inequalities, are assigned to later times of the day and attention declines in the afternoon. It could be that women speak on topics that generally receive less attention, and there are many other ways that, that could drive those results. We cannot perfectly test those things, but we're trying to get an idea whether like this is something that drives the results or not. To do this, we refine our estimate slightly. So instead of just comparing all speeches by women with all speeches by men, we're now trying to hold some covariates constant so that we have comparable speeches. This means that we are extending the linear regression model with listener fixed effects and with entropy balancing weights that balance speeches by men and speeches by women with respect to a wide series of covariates. We include type of debate here. We include the length of the speech, number of speeches during the debate as a measure of how important this debate is, vocal pitch as a measure of how emotional a speech was given, seniority of the speaker, topic expertise, and length of previous speeches in the session gives us an idea about how late in the day the speech is, and so on. If we do this, the results don't really change. In fact, they keep being pretty much the same. On average, we see women receive less attention than men. As soon as we split this by men and women in the audience, we see, well, it's men who listen less to women. We don't find out any evidence for differences among women in the audience. We also do some robustness tests. This is mainly motivated by the fact that this sort of data, if you work with this sort of data, you have to do lots of data pre-processing decisions. You need to decide like how long does a legislator need to be visible so that we use them in the data set, many of those things, and we want to make sure that those decisions don't drive our results, which is why we did a specification curve analysis where we vary all those decisions and repeat the analysis, and we see that for the main finding, this doesn't really make a huge difference for what we find, so that's good. Okay, so to wrap up, we are asking in this research project whether legislators pay less attention to speeches by their female colleagues as compared to speeches by their male colleagues. We use computer vision techniques to analyze video footage that shows legislators while they sit in parliament. Our results show across many different models that women on average receive less attention than men in the Landtag Baden-Württemberg, and that this difference is exclusively driven by the men in the audience, not by the women who seem to pay equal attention to both men and women. There are some limitations to the study. I want to acknowledge those that I think are the most important ones. One is that we are studying one very particular case, the Landtag Baden-Württemberg. What I think is a particularity that should be acknowledged is this gender composition of the Landtag. Women are underrepresented and they are concentrated in few party groups. There's lots of research that came out in like recent years that shows that gender composition of deliberative bodies makes a difference for how the deliberative process works. So it would be very interesting to see, like, if there are more women, does the pattern change? And we cannot give information with our data on that. The cameras don't always capture the entire audience, so the analysis comes with some assumptions. I think that this is not a super big concern, given the robustness of our results, but it still should be acknowledged. And this is, of course, an observational study, which in my opinion is a plus and a minus at the same time. It's good because like it's a real parliament and we can show what like many women reported on their own experience. They can use this data to try to, or we can use this data to try to raise awareness about this. At the same time, if we really want to understand the mechanism behind those, is it just gender, or is it as I like those arguments that I said before, maybe women speak later in the day and this drives the results. We cannot make sure, we cannot rule out that such mechanisms drive the results. Experiments could help to study this further, but at the same time, we cannot do experiments in parliaments. Okay, that's the talk. Thank you very much for listening. I'm happy to try to answer your question. I'm also happy to receive feedback. If you're interested in the paper, you can write me an email. I'm happy to share the latest version of the paper. Thanks.
Excellent. Thank you, Oliver, for the very insightful talk. So 1 second, I will, if you would unshare your screen.
Yes.
I will share. I have all of this figured out on my end. So let me do this. Like that, and boom, boom. All right. So yes, here is Oliver's contact information. If people are interested in learning more about his work. So let me check out the participant list here. Okay, we can now open up the floor to questions. So the way that this will work is raise your virtual hand, so the little hand emoji. That'll put you in the queue. I will unmute you, and then you can ask your question. Yeah, so I'll give some people some time to, perfect. So Shane is first up, so I will allow Shane to, let me unmute him. Sorry, let me just do it like this. Okay, Shane, go ahead and unmute yourself. You should be able to.
Can y'all hear me? Okay,
yes,
perfect.
Yes. Go ahead.
Oliver, this is fascinating stuff. I really enjoy this presentation. I'm definitely going to email you for the paper. I'm curious, this particular state, just how is like the political cultural dynamics of that state? Is it more liberal, more conservative? How does it compare to the rest of Germany?
Thanks, Shane. I guess should I answer right away, or should we collect questions?
I'm fine with you answering right away. That's probably
right.
easiest.
So thanks for the question. So Baden-Württemberg is a state that for a long time had a Christian democratic government, and it now since quite some years has a Green-led government in a coalition with the Christian Democrats. As a rather conservative. It's a Green government, but also the Green Party in Baden-Württemberg is like in Germany is a rather conservative wing of the Green Party, which means that compared to other states in Germany, I would say that there are, of course, like it's still a Green government right now, but I would say in Germany it's rather on the conservative end. And on the left end.
Okay, so it'd be very fascinating to see if these results would hold in a more quote unquote liberal state as well. And that's probably creating more work for you, but it's a fascinating future direction.
I agree.
Thank you.
Thank you, Shane. Next up on my list would be Carl Emil. Hopefully I did that right. Go ahead, Carl.
Yeah, thank you, and you did it perfectly. And thank you for hosting this, and thank you for presenting. I find it very fascinating and interesting. I noticed that in your coding for pre-trained data, much of the coding for inattentiveness was also people looking down or something like that. Have you considered using like gaze estimation, where you like measure the direction of one's vision, like what you're looking at? This would then require much less coding for pre-trained data and make the method more applicable for other settings, I think. But I'm looking into it myself, but I have not. So I thought maybe you have considered.
Thanks. So you are right. So we had a code book that basically said, told the coders to code according to gaze direction. So this would make total sense to look at gaze. You cannot definitely say that if somebody watches down that this person doesn't listen, but this was what we think is what we can distinguish based on the video recording, based on those pictures. Regarding like what models exactly we used, this was always Tobias' decision, so I can't give you an answer on that. We use this sort of architecture a lot, and it works quite well. So I can imagine that for Tobias, like it's something that he has no problems applying, because he's applying those pre-trained models all the time. But I agree that models with like a general task, such as gaze direction detection, are something that are worthwhile testing here, because they allow to like apply this to other parliaments. I'm right now also working on a paper that tries to measure something different, but also with the goal to use those general models using pose estimation, which can generally apply to different types of parliament where you don't have exactly the same cameras. So that's a great point. But we didn't do this here.
Right. Thank you, Adam.
Thank you, Carl. Next up on my screen is Mohammed. So take it away, Mohammed.
Thanks, Oliver, for the great talk. And it's kind of scary opening the camera during this talk, because I feel like I'm running the code in the background, seeing who's paying attention or not. So I hope we passed. Anyway, so the question is, sorry if I missed that. Like, I'm not sure how long was the time period, like for the videos that you collected, because I feel like now it's like you have a snapshot or like a cross-sectional data. I wonder if you could, like, if you had enough videos long enough, you could see a trend, or like longitudinally say something about if there's a trend here. Okay.
Yeah, so we analyzed 1 year, and that's definitely a snapshot. We don't have the, like, we can go back in time. The way this worked was we got like the agreement with the Landtag. We started the collaboration with the local broadcasting company that maintains those cameras. They would upload the video footage to a server, and we could download them within a week after the meeting. And we did this for 1 year. And with this, like, it had to happen directly after the meeting. I'm not sure whether they have an archive where they collect this footage, but I don't think that they have an accessible archive, at least. It would be great to see this like over multiple periods, but we don't have the data. We really have this one snapshot. That's what we have to work with. I'd be very interested not only to look at other parliaments, also to look at the longer time frame. But yeah, I'm happy that we have this 1 year.
Thank you, Mohammed. Next up on my list is the man, the myth, the legend, Robert Browning. So take it away, Robert.
Yeah, and thank you so much for doing this, and fascinating to see. And my mind is racing through the archive, thinking of what kind of videos we have that we could do this research with. But 2 technical questions. One, first, you kept showing in the pictures people reading or looking at their phones, but in the coding, you were only looking at their faces, right? Only looking whether they looked straight ahead or down. So you infer from there that they're looking at something and not paying attention. And then my second question is, did everybody have the same length of time that they were listening? I mean, you have the length of time of the speech, but were all the participants, the subjects all watching for the same amount of time?
Thanks. So first question. Sure, we look at the faces. I mean, I showed those examples of the labeled pictures. We kind of had to make a decision at the very beginning, like how we are going to go about labeling. And we decided this based on the idea that we want to have a code book that gives coders a clear idea how they need to label, and has like very little room for interpretation. And we found that talking about whether they look up or whether they look straight ahead or somewhere else, which is mostly on their phone or something else. This is what made us decide to code them as attentive or not. We are aware that you could look somewhere and still pay attention. I'm also often saying, like, or the legislators are less listening. We don't really know whether they listen or whether they don't listen. We only have the information on whether they look ahead or not. So this was kind of a practical decision, also because I think that this is what like the network could infer most easily. Also, like going through those images that we had to label, it's often not so clear, and if we would add more nuance to that, it would make it more difficult to label those, and then also more difficult for the network to learn those labels. Second question is also a very good question. I appreciate that. So no, that's not the case. The camera moves from here and there, and sometimes during a speech, one legislator is detected for like an entire 5-minute speech, but the other one only for half of the time. In the analysis, we wouldn't differentiate between that. What we do have is some rule. So we have a rule that says the legislator has to be detected for at least 20% of the time or 30% of the time. That's one of the pre-processing decisions I talked about in order to be included in the data set. And it's clear that this is a critical decision, and that's why we did the specification curve analysis, where we tried out different values, like how long do they have to be detected in order to end up in our data set. And we've, like, the specification curve analysis showed that this doesn't really change the results. That's like what I think is most that we can do. We need some sort of rule, like when to include them. There is the downside that not the entire parliament is captured and that the angle changes. And yeah, that's how we dealt with it.
If I can follow up, you talked about the number of sessions, the number of speeches, but you never mentioned the number of images.
Yes. I can, lots of images.
And lots of them. I'm just wondering what the scale was.
Yeah, that would be interesting. I think I could calculate that. I don't have a number right now.
Okay. All right.
But I try to calculate that. Shouldn't be that difficult. I mean, we have to, like, basically the data.
Yeah. Okay.
Thank you, Robert. I will ask a question since there's nobody currently in the queue. We have about 7 more minutes left in the session. So if you have a question, feel free to raise your hand emoji. So my question deals with the topic of what is being discussed. So I'm interested to see whether or not you've done any preliminary work to see whether or not attentiveness increases or decreases when women are talking about certain topics or men are talking about certain topics. Thanks.
Thanks for the question. It's the question that I'm asking myself. So we didn't do this yet. I think, especially in light of the research that came out recently and that's been done on interruptions, on clapping, applause, stuff like that. There's lots of evidence like that came out in recent months and years that kind of shows that, like, role congruency theory is something that we can use to explain this. So that attention behavior depends on whether women speak on topics that are congruent to the roles they are that exist or that people think they should fulfill or not. I think that's interesting. It's something that I want to do, and right now, yeah, thinking about whether this should be part of this particular paper or should be part of another paper. It's especially in light of like latest evidence, it's something that I want to look at. Hopefully there's enough variation in topics over the year that we have data on, but we didn't really check that.
I would say my 2 cents is that including I would only focus on topics that are typically associated with female legislators in that setting, because the confounding variable could be that men are not paying attention to female legislators. They're not paying attention to the topics that they're typically advancing. Now, obviously, that's still not good because there's differences in terms of the issues that are being discussed. But even if you do something that is just like women talking about women, so you don't even dip your toe into like women's issues and non-women's issues, but you just look at whether or not they're talking about women as a group, you can cite a number of papers that say women are more likely to reference women. And so then that helps get traction on this potential confounding factor.
I agree. Thanks.
So I accidentally muted Oliver, so please recognize that, Oliver. Sorry about that.
I said I totally agree, and thank you for your comment.
Right. So Miriam, feel free. The floor is yours.
Thank you, Bryce. So Oliver, first, I really enjoyed your presentation. I think this is great work. My question is related to gender quotas in that state. Are there any gender quotas implemented in this state that you're focused on?
There are no quotas in the states. The Green Party usually has quotas. The electoral system of the state is not super straightforward, or it's not super complicated, but it's not straightforward to enforce quotas in parliament, because you have like electoral districts, and then to end up with a quota in parliament, that needs some thought. But it's not a coincidence that the Green Party has almost as many women as they have men. This is a party that in Germany typically enforces parity. Other parties don't. So, and I think that's like the only quota, even if it's a soft quota, that exists.
Right.
There.
Right. Some, as far as I know, some parties in Germany have voluntary quotas. And one thing that I would be interested in is that, like, if you control for the fact that are these women elected through like a quota system or something? Because there's literature that says male politicians are more likely to disregard women who find their way into the parliament through a quota system because their qualification and merit is under question. So yeah, that might be interesting to look into.
Absolutely, thanks. That's a great suggestion. Yeah, I'll take a note. Okay,
and with that, I think it's a good opportunity to wrap up here for the last couple of minutes and talk about what is next on our schedule. Next will be myself on April 7th at 2:30 p.m. So what we were going to attempt to do this semester is that we've had very interesting talks in part 1 and 2 of the video workshop series. My talk is going to be much more hands-on in the sense that I will give you code distributions and things of that sort to help you do facial recognition in your own work. Afterwards, we will submit a survey via social media where you can assess the workshop series, give us some feedback, how we can improve for the following semester. But with that, I'm happy to close today's session. Thank you, Oliver, for the fantastic talk. Thank you for everybody participating, especially those overseas who are not in the United States. It's a late night, I get it. So thank you so much for participating as well. Really appreciate it. Thanks.
Thanks for inviting me. And thanks for all the comments.